The model of the solar system we usually see shows planets spread evenly around a central star. In reality, the scale looks more like this. The Sun accounts for 99.86% of all matter in the solar system. The remaining 0.14% is everything else. It is roughly 330,000 times more massive than Earth. 1 million Earth-sized spheres could fit inside its hollowed volume. There is no balanced system of equal worlds here. There is only a single star and a tiny margin of rocky and icy debris caught in its gravity. To understand how this system operates, we have to look closely at how this dominant sphere of hydrogen and helium actually functions and what makes up that leftover 0.14%. Every environment humanity has ever known exists entirely within the microscopic shrapnel of a single star. Deep inside the solar core, temperatures reach 14 million Kelvin. Under these extreme conditions, hydrogen nuclei are crushed together in continuous nuclear fusion. This diagram details how energy moves outward. In the radiative zone surrounding the core, energy transports slowly through the dense plasma. As it reaches the outer 29% of the solar radius, the mechanism changes, showing circular convective currents conveying heat upward. The tops of these convective cells reach the visible surface, appearing as bubbling, transient patterns called granules. A single one of these granules stretches 1,500 kilometers across and lasts for just a few minutes. The sheer volume of this engine is massive. Light traveling at almost 300,000 kilometers per second takes over 2 seconds just to cross from the Sun's center to its edge. The star regulating the inner planets is a turbulent, churning heat engine, operating on a scale that dictates the physics of the entire inner system. To sustain its immense luminosity, the Sun is actively destroying its own mass. This mass loss occurs through 3 primary mechanisms: the conversion of mass to energy, the continuous flow of solar wind, and massive coronal mass ejections. Through these processes, the Sun steadily expels between 2 and 3 times 10 to the negative 14th solar masses into the void every single year. The gravitational anchor holding our planets in orbit is a slowly leaking reservoir of matter. The fraction of matter that escaped consumption during the Sun's formation makes up the remaining 0.14%. This debris settled into a distinct hierarchy. The inner group consists of terrestrial planets: Mercury, Venus, Earth, and Mars. These are comparatively dense, featuring iron-rich cores enclosed by rocky mantles. Moving further out, we find the giant planets of the intermediate system. Jupiter alone contains the vast majority of all non-solar mass. This intermediate zone also contains diverse structures, like the complex icy orbital rings encircling Saturn. Past the giant planets lies the Kuiper Belt, a region populated by smaller, frozen objects like Eris and Pluto, characterized by its nitrogen ice glaciers. Every planet, moon, and asteroid observed locally is simply the trace residue of a much larger stellar event. The Sun's gravitational reach extends far past the Kuiper Belt, tethering objects in the absolute freezing edge of the system. Between 5,000 and 100,000 astronomical units away lies the Oort cloud, a thick spherical shell surrounding the inner system. This boundary is populated by up to 1 trillion icy objects. They move slowly through the dark, easily perturbed by passing stars and the tidal forces exerted by the Milky Way galaxy. To grasp this distance, consider the Voyager 1 probe. It is the furthest human-made object from Earth, yet it will still take another 300 years just to reach the inner edge of the Oort cloud. Because it is entirely devoid of sunlight, we cannot image the Oort cloud directly. Astronomers infer its existence from the long-period comets that occasionally fall inward toward the terrestrial planets. The edge of the solar system fades slowly into 1 trillion frozen bodies, caught in a gravitational tug-of-war between our star and the rest of the galaxy. The ongoing loss of solar mass will eventually alter this entire cosmic structure. When the Sun enters its red giant phase, its mass loss rate will accelerate violently. It will swell outward, expelling its glowing outer layers of gas to form a planetary nebula. By the time the core collapses into a degenerate white dwarf, the Sun will have permanently shed 46% of its starting mass. With nearly half of its mass gone, its gravity will weaken proportionally, loosening its grip on everything from the inner rocky planets out to the Oort cloud. The solar system is a temporary evaporating structure, destined to eventually release its hold on the fraction of a percent it leaves behind.